All right, well, I'd like to thank you guys for having me here on the stage today. This is pretty impressive. I'm going to be speaking to you about a project that I was on with Niagara Research, my first project with Niagara Research, which I spent 4 months working on, that ended in March, with a company called Decora Powder Solutions. So the project team consisted of myself, Josh Buns, which was another student on the project with us, and our project lead was Rick Baldwin. So a little bit about the company. Decora is a family-owned business. They've been serving the community for 30 years with some pretty impressive customers, such as the big 3 automotive groups. They have a staff basis of over 50 employees, full-time employees, and they now are pretty proud to introduce their Decora, or rather Decoral product, which I will show you right here. So essentially what the Decoral product is a basic powder coating process that finishes with a decorative sublimation finishing, which is basically a film with a decorative ink that would be vacuum sealed to a previously powder coated material and baked into that material so that that ink can be kind of drawn into that powder coat base. Now the issue that they were having is that finish relies entirely on the thickness of that powder coat application, and more specifically the uniform thickness of that powder coat application. And previously they were unable to find out the thickness of their powder coat application before it had been through the ovens and been cured. So we had, they'd been using a contact gauge to tell them the thickness of their powder coatings after the cure, which I used in comparison with another gauge called the Alcometer 550, which was a kind of an echo laser. And what it would do is it would shoot echoes at the material. It would find out the resistance between the gauge and the base material, and it would give you a linear measurement based on that. And that linear measurement is the raw linear measurement of that loose powder on the metal base. And the goal was to use this gauge to find the actual measurement of the cured powder on that from the raw state, which took some time and some looking around. But what me and Josh had discovered, and now I've lost my clicker. What Josh and I had discovered is that there is only one variable within the gauge that we were able to manipulate, and that was, it was labeled as distortion. We're not incredibly sure how that worked within the gauge, other than that it distorted our values, but we found a correlation to the base of the powder coat, whether it was a polyester base or a silicone base, as well as the base material and the line speed and oven temperatures, and we had to take all of those things into account when testing. So what it would do, or rather, I'll start with our phase 1. Phase 1 of the project, there was 3 phases, and we had to source the gauge, for one, to find out what we could use to get these information for them. And we found that there was only really 2 gauges on the market. There was the Alcometer 550 Mark IV, and then there was the OACETT PC powder checker, sorry. And the 2 gauges were very accurate. They had very similar accuracies. The only difference that we found was good for us was that the Alcometer was able to take a series of several measurements on a strobe-like basis in a second. So I could take 50 to 100 measurements in 1 second. Whereas with the OACETT, you're left with 5 seconds to try and get one reading. And based on the scenario that we were in, all the parts are moving on a moving line throughout the whole facility constantly. So in order to take a reading, you only have about 15 feet between the end of the powder booth and the actual oven to take a reading. And in many cases, they're swinging, moving, they have very complex geometries, and you're lucky to get a reading at all. So with the use of the Alcometer gauge, if you could get a split second of accurate reading on the material, you could have 40, 50 measurements that you could use to average and have a good solid number. So we ended up going with that. I keep putting the clicker in my pocket here. So with that, we decided that we needed to figure out a way to collect this data. And what happened from that was we actually found 2 methods. Because we didn't want to interrupt the flow of the facility. We were able to find a way to work with the floor staff, the pickers, and those people to try and take data as it was moving along the line. And then the more preferred method was if we would just kind of wait for them to go on lunch and stop the line with a part between the oven and the powder booth. So we would have a good hour to take a large amount of measurements, and that was usually our best results. It also allowed us to take some more special paints, such as they had vein paints and other textured paints that were very difficult to get an accurate surface reading in a very small zone after it's been cured. So we would want to take much more. So for something like that, where I would normally take 20 measurements, we would do 100 or so over that time period. And then after the cure, we would be able to take it off the line and do another 100 measurements with the contact pause detector gauge. And then we were able to, after getting pretty familiar with the gauges, produce standard operating procedure for both gauges so that they could be used by the staff as well. Phase 3, analysis of that data. Essentially what we were finding actually after we started analyzing our data is we were looking for trends. And we were starting to see them, but we were also starting to see discrepancies in those trends. And what we learned is that there were a lot of variables, or a couple of variables that we hadn't taken into account, such as the engine or the oven temperatures rather, and the line speeds and things like that. So we brought in a couple extra pieces of equipment. We brought in the temperature gauge, and we were actually able to write off the temperature of the product when being measured as a factor when it's being measured, but not the temperature of the cure. The cure actually seems to affect the result of the paint on the material. So we were able to add those to our datas. Pardon me. And yeah, we were able to come up with a rather accurate sheet. So this is an example of what I would have done for one of the tests over a lunch period. So I would have taken 20 measurements. Each one of those columns on the left side is going to be a string of 20 measurements. Oh, geez. On these guys. And up at the top, we have each different distortion level that we were choosing for the gauge. So at first, without any previous knowledge, we would just take a wide range and do 20 measurements across it and record them all. And then after it had come out of the oven, we would do another 20 with the contact gauge, compare them, and then I just had a couple of little bits of code in here that would give me some answers, averages, minimums, maximums, means, on how close the two measurements were. And eventually we would use that to find a specific distortion setting for the gauge based on that paint, material, oven temp, and line speed for them to use in the future so they could see their cured measurements. And this is what resulted of all of that. So I was able to come up with this kind of cheat sheet for them. So based on the base material and all of the other factors involved, you can choose your distortion so that you can know without having to run back and forth or spend the time of actually curing the part and know what's coming out at the other side. And the benefit of this to them was, for any powder coating facility, would be mostly for cost savings. Essentially, a lot of the parts that they would powder coat were things like garbage cans, tiller blades, construction fencing. In those types of situations, as long as the part comes out as a solid color, if it comes out black or orange, it's essentially a pass. But where they're concerned is it heavy? Are we spending twice as much paint on that product as we need? Are we not painting it enough? And this gives them that tool to find that out. But more importantly is with the Decora product, they're able to consistently and reproducibly make matching decorated panels. So if they were to make, a good example actually is we made 250 maple wood panels on aluminum sheets that were to cover a building in Vancouver. And they were super excited about them when they received the panels. They called us, they said, wow, we're really impressed, we want a lot more of those. So that's where we ran into our first issue, was that we don't know how thick it was, we don't know how fast it ran through the line, how hot it was. So the second run was significantly darker than the first run, and they were able to show that to us with a nice big brown L on the side of their building. And they commented rather strongly towards that. So I made a side project on that to kind of compare what we had sent them the first time to what we had sent them the second time, and I was able to come up with a recipe, so to speak, on how to recreate those first panels, and in doing so also to have a kind of a goal to shoot for when making another run of panels for another customer. and it makes things a lot easier to become uniform. Oh yeah, one of the unexpected results actually of having this gauge in use is I was communicating a lot with one of their manual painters on site and updating him with kind of what we were doing. And I provided him with the final distortion chart to play with and kind of give me feedback. Does this work? Is this complicated? Is it confusing to you? And he was actually able to find in his downtime when the machine was running automatically, just through playing with the gauge, discrepancies actually within their machinery and their equipment that was causing problems with uniformity right from the very base of the facility, which is really where the beginning point of the application. So they need to sort of tackle those things. And they didn't really have anybody in the facility in place that had the time or the expertise or really the need to be focusing on those things. So I was able to pull out on the right side there, you'll see there's a couple of little boxes. Those are airflow control modules, which were in their automated booth. And you can see sort of, it's not a very great picture, but on this you can see that these holes have some cracks along the edges. And they were producing a huge air leak, enough that it would actually distort the skin on your hand if you put it around it. And you can imagine that that air is probably going somewhere. And so we were able to pull those out. We found that they were very difficult to acquire, but eventually we were able to get them in there, and they've greatly improved the quality of their product just through that. And that was really more of a kind of a side perk, if you want to call it that, of the project. And there's so many more applications for this gauge within the facility. So as an end result, I've benefited dramatically from this type of an experience. I've always been kind of a hands-on sort of cars guy, and you know, I used to tell my dad, he's a lawyer, I'd never wear a suit ever. I don't care if at my wedding I'd be in a t-shirt. And he said, you know, let it go. We'll see what time does. And he was right. As soon as I found Niagara Research, I've absolutely found my calling with this. It's having a different task and a different project and a different mindset every day is quite refreshing. And yeah, they've done a great deal for me. So I'd like to thank you right now for letting me speak with you guys. And I'm going to give you guys some time for some Q&A if you have any questions.